Good afternoon, professors. Good afternoon, Sonia ma'am. Welcome,
Ma-
ma'am.
yeah, ma'am. Good afternoon, ma'am. Again, like yesterday, I was trying to connect through my system, ma'am. I'm
Okay.
having a problem. I don't know
No.
what is happening. The microphone is getting switched turned off. It
Oh,
says the call size is large. I don't know why.
oh.
That was why the delay, ma'am. Sorry.
No problem, ma'am. You just present using mobile itself, ma'am. Even that
Yes,
is
ma'am.
comfortable for us. No problem, ma'am.
Okay, ma'am. So can I start, ma'am?
Yeah, ma'am. You can start your presentation, ma'am.
Yes, ma'am. Thank you. Ma'am, is my screen visible? Ma'am?
Ma'am, yes, ma'am. It is visible,
Ah,
ma'am.
okay. Yes, ma'am. Thank you. So, good afternoon, all. Again, it is really happy to meet you all in the second session. So, today's session is again going to be about minimum spanning tree. So, coming back, what a minimum spanning tree is all about is generally, let's just take this example. If I want to travel from Chennai to Madurai, I see which is the shortest path out of all distances. There may be various paths. Either I can go to Trichy and come, or I can either take from Dindivanam. Any route is there. So minimum spanning tree, okay, let me just take it's like an example of where I try finding the shortest distance. Not only in case of my location, I can even take an example where I consider maybe okay in my lab I want to connect multiple systems in that case. So multiple systems in the sense, for instance, what to say? Maybe I'm going to have five computers which have to be connected. In that case, I can either give a direct connection, or what I can do is I can even give multiple connection. So again, here I'm trying to find the smallest path here. So there are two ways, there are two algorithms which I use, either my Prince-Jarnick algorithm or my Kruskal's algorithm. So coming back, okay, let me see what is the minimum spanning tree. So spanning tree is nothing but I should ensure that I cover all the nodes. I should cover all the places. That is what is important there. But I take the one with the less weight or the less cost. So example, this was the example which I was talking, connecting all the computers in the building with the least amount of cable. Example, another important thing is that minimum spanning tree is not always unique. I would even like to share with you all another example which I had prepared for my class. So I will just show you that. That will again be a bit easy. So this is a thing which I want, which I'm having a graph. I'm having five vertices. What are they? One, two, three, four, five. So here I want to find out a minimum path or the spanning tree which I want to create. So when I'm trying to create here, the first tree is where I'm here 1 to 2, there is a connection. So the weight is going to be from 1 to 2, it is going to be 1. 2 to 3, it is going to be 4. So total weight is 5. 3 to 4, it is going to be another 5. So 5 plus 5, 10. 4 to 5 is another 2. So 10 plus 2 is going to be 12. Okay, this is one. Another person comes and draws the spanning tree. When that person draws the spanning tree, the second one maybe he doesn't want the edge between 2 to 3. And when I'm finding the total distance, I'm having only 11. So when I compare 12 and 11, I feel my 11 is going to be a shortest distance, at least by 1 kilometer. Okay, another property of my spanning tree is that the number of edges, that is, the ones which connects the vertices, will be always minus 1 the original graph. Okay, here for example, here in my above graph, how many edges do I have? 1, 2, 3, 4, 5. In my spanning tree, I'll have only 4. This is one among the property. So this was the example which I prepared for the class. So again, yes. So the minimum spanning tree is not always going to be unique in the sense I may take one path and the other person may take another path. Sorry. Okay, yeah. Hmm. So each of us prefers our own path. So that is why they say minimum spanning tree is not going to be a unique one. Okay, now let me just tell what are the properties of a minimum spanning tree then. Yes. So yeah, if the minimum spanning tree does not contain a minimum weight edge, then what do? Is we try finding a better or an equivalent edge. And then here comes the Prince algorithm. What I thought was I will just try explaining it with my material and then I will try going with a PPT. This will be much easier and it will just give us a better overview. Yeah. So first what I will do is we will just go through our Kruskal's algorithm. So again, coming back to Kruskal's algorithm is again going to be a very greedy technique of a minimum spanning tree. So what I try doing is I try finding the minimum edge. Okay, the edge which has a minimum weight. Okay. So how I will draw is, let me just take this example. Yeah. Yeah. Let me take this example. So here totally I have how many vertices here I'm going to have. My vertices here are, I'm going to have my vertices as A, B, C, D, okay, and then I have multiple edges here. So initially I'm just going to draw my vertices. Ma'am, is my screen visible?
No, ma'am.
Okay, just a second, ma'am.
Yes.
Ma'am, is it visible now? Ma'am? Ma'am, is it visible now?
Ah, yes, ma'am. Yes, ma'am. It's this.
Yes, okay. Thank you, ma'am. So, yes, what I will do is we will go through with the PPT later. So, I think this notes will be really very helpful. This was the one which I collected from multiple sources for my students. So, I felt this will be easier when going with the actual PPT. So let's start with the Kruskal's algorithm first. So as we just started, Kruskal's algorithm is going to be one among the greedy techniques to solve a problem. So yes, so what I will do is here, this is going to be my graph. Yeah, okay. This is going to be my graph. I, uh, okay. The graph is slightly tilted. Just a second, I'm just trying to.
Okay, ma'am.
Yeah, okay, the graph is a little tilted. Okay, I think it is visible now. So, okay, this is going to be my graph. And here in my first image, I have totally 7 vertices. So my first step is going to be, I am just going to draw my vertices. So without any connection. So this is step 1, where I just directly draw my vertices. So I'm having V1, V2, V3, V4, V5, V6 and V7. So what is going to be my second step? The second step is where I am, ma'am, is my screen visible?
No, ma'am.
Yes.
Just now it got wiped up.
Ma'am, now it's visible, ma'am.
Okay, yes, thank you, ma'am, thank you. Sorry for the trouble today. I don't know what is happening.
Ma'am, no problem, ma'am.
Oh, thank you. Yeah. So again, as I was just telling, Ah, this is going to be the example which we have taken. So what we are going to do is the first step is where I draw all my vertices. We are going to have totally 7 vertices in my given graph. And then what do I have to do is I identify which has the minimum cost here. So can some, okay, so what is going to be the minimum cost here? My minimum cost here is going to be 1. Okay, cost, you can either tell it as cost or weight. In real time example, we call it as distance. So the minimum one is going to be the one between V1 to V4 or V6 to V7. So what I'm going to do is, yeah, so what I'm going to do is here in my case, so first as I was just telling, we can either take two, either V1 to V4 or V6 to V7. So let me just take, now I have to start connecting the vertices. So first one I'm going to draw between V1 to V4, step 1. So this is my step 1 where I just draw all the vertices. Coming back, the second step, I draw the connection between V1 to V4. Okay. So what will be my next step? Obviously, I'll have to connect V6 to V7. This is what I'm going to do here. So if first one V1 and the V4, there is one V6 to V7. So what is the next minimum value which I'm going to have here? So 1 is over. Now I'm going to have 2. So which is going to be 2? The one between V1 to V2 or V3 to V4. I can do the connection like this here. So I finished my 1. So the next one comes here. I'm going to do what? V1 to V2. Similarly, I make sure I complete the graph. So the thing here is I have to just connect all the vertices. It needn't be that I have to connect all, that is, each vertex can be connected only once, that will be fine. For here, in this case, this is going to be my last diagram here. This is going to be the minimum spanning tree here. So how do I calculate the cost for this? So V1, and from V1 to V2 it is going to be 2, 2 plus 1, 3, 3 plus 2, 5, 5 plus 4, 9, 9 plus 1, 10, 10 plus 6, 16. This is how I calculate the distance or my total weight. This is going to be my Kruskal's algorithm. I just repeat it. Kruskal's is going to be one among the Kruskal's is going to be a greedy algorithm. Here, what I do is I first initially find out what are my points, that is my vertices that I have to visit. Second, what I do is I am going to identify the minimum distance. Here, in my case, the minimum distance was 1. So I first did my connection as from V1 to V4. I am finding the next minimal value and I ensure I create the minimum spanning tree. And my total distance is going to be 16. Does anybody have any doubt in case of my cruscals? Any doubt with cruscals? Any
Ma'am,
doubt
no.
with cruscals?
No, ma'am. No, ma'am. It's clear, ma'am.
Yeah, I will again share
No,
the
ma'am.
material also. Yes, thank you, sir. Thank you, ma'am. And then again coming to prims. Prims is again going to be the same thing. As I just told you, I don't want to use the PPT. I will use the material which I just shared with my students. So for the crystals, sorry, for the prims, let's just have a look at this. When we have a look at this, the other one is going to be easy for us. So this is my example which I have taken here. So here I'm going to have my vertices are from A, B, C, D, E, F. These are going to be my vertices. So my first rule is that I have to remove any loops. What do I call a loop as? Generally, for example, of okay, I'm going to have a from for example here B to D there is a distance as 6 and from again B to D it is going to be 8. One more thing here is we do not have any directions. So adnala we don't have any problem. B to D 6, B to D again 8. So what we do is we take the path which has the minimal weight. Abdina, what will we reject? We will reject the path which has the higher weight. So which path will I take here? I will consider my 6 and obviously I will leave what? I will leave my 8 there. This is the first step. Second step is what is I will remove my the and the cycle Mari is coming. Where do I find any cycle here? I find the one F learn the F க்கு வருது. So I remove that also. So my first step is over. So now I'm going to start my work. So this is going to be my graph here. So now I have to create the minimum spanning tree using Prim's algorithm. Okay, இப்போ பார்க்கச்சுல first one. Okay, so generally what we do is in any example நம்ம vertex B1 root எடுப்போம் இல்லைன்னா A root எடுப்போம். ஸோ இங்க நான் வந்து again நான் A root எடுக்கிறேன். ஸோ Aல இருந்து ரெண்டு distance இருக்கு. What are they? I either have 7 or I either have 8. 7 and 8ல வந்து எது minimal distance நம்மளுக்கு 7. ஸோ அதனால ஏல இருந்து பிக்கு வந்து ஒரு கனெக்ஷன் போகுது. தட் இஸ் கோயிங் டு பி 7. நெக்ஸ்ட் ஸோ ஏ டு பி பாத் ஓவர். இன்னும் ஏ டு சி கனெக்ஷன் அப்படியே இருக்கு. நவ் ஐ மஸ்ட் கன்சிடர் பில இருந்து எங்கெல்லாம் போகுது. ஸோ லெட் மீ கன்சிடர். ஸோ பில இருந்து எங்கெல்லாம் போகுது? ஒன் வந்து மேபி ஐ கேன் ஜஸ்ட் செக் த வேல்யூஸ் ஆல்சோ. 3, 6. ஓகே, 3 and 6 பாக்கெட்ஸ்ல எது மினிமல் வேல்யூ? ஆக்சுவலா பாக்கெட்ஸ்ல நம்ம எப்படி பார்க்கணும்னா 8, 3 and 6. ஏன்னா 8 ஒன்றும் பெண்டிங்ல இருக்கு. 8, 3, 6 நான் பாக்கெட்ஸ்ல எதனோட மினிமம் வேல்யூ 3. ஸோ அதனால நான் 3 கன்சிடர் பண்றேன் ஓவர். ஸோ இப்போ அப்படின்னா எனக்கு எதெல்லாம் பாக்கி இருக்கு? 8, 6 இருக்கு. Now next Cல இருந்து இதெல்லாம் எனக்கு வெளியே வர கனெக்ஷன்ஸ். I am going to have 3 and 4. Which is going to be my minimum value? 3 is going to be my minimum value. So I consider my 3 here. So அப்படின்னா இந்த எட்ஜும் வந்துருச்சு C to E. Now Eல இருந்து எனக்கு ரெண்டு vertices இருக்கு. So either my D or my F. So let me take my D itself here. DO FO. ஸோ நான் D எடுத்துக்கிறேன்னா ஈல இருந்து டிக்கு வந்து 2. ஓகே, நம்ம இப்போ டீல இருக்கிறோம்னு வச்சுக்கலாம். இப்போ டீல இருந்து எனக்கு இன்னும் அன்விசிட் பண்ணாத வேர்டெக்ஸ் எஃப் தான். ஸோ நான் இப்போ நான் விசிட் பண்ணச்சு நான் பார்த்தேன்னா எனக்கு என்னெல்லாம் இருக்கும்? ஸோ இந்த இதை நான் எடுத்துக்கணும். டி டு எஃப் 5ன்னு இருக்கு. ஓகே, வேற என்னெல்லாம் நான் விசிட் பண்ணாம வச்சிருக்கிறேன்? இந்த இ டு எஃப் 2வும் அன்விசிட்டட். 5வும் 2வை விட எது லெஸ்ஸா இருக்கு? 2. ஸோ ஐ டேக் 2. Yes, so this might be a little confusing. I would just repeat it again. இந்த ஃபர்ஸ்ட் இதை மட்டும் நம்மளுக்கு கிளியரா புரிஞ்சிருச்சுன்னா that's going to be easy. In case of my Prim's algorithm, step 1, remove any cycles if we have. Step 2, again அந்த loop source cycles remove பண்றோம். Next, select any source vertex or the root. Here in my example, A is going to be my root. So if A is going to be my root vertex, what is the second step which I am going to do? A ல இருந்து எங்கெல்லாம் வழி இருக்குது? So சென்னையில இருந்து இந்த பர்டிகுலர் இடத்துக்கு போறதுக்கு எனக்கு எங்கெல்லாம் வழி இருக்கு? I am gonna search. So I find B and C. There are two places. So A to அதாவது 7ம் இருக்கு 8ம் இருக்கு. So obviously 7 is going to be a minimal value. So I consider 7. The next step is what I should do is, so from B இப்போ நான் வந்து B ல இருந்து அடுத்த பாயிண்ட் பார்க்கறதுக்கு முன்னாடி நான் என்ன கன்சிடர் பண்ணணும்னா ப்ரீவியஸ் ஸ்டெப்ல எது அன்விசிட்டட் ஆகாம இருக்கு. ஸோ 8 இஸ் அ வெயிட். ஸோ 8 நான் வச்சுக்கணும். B ல இருந்து போற வெயிட்ஸ் நான் வச்சுக்கணும். 8, 3 and 6. 8, 3 and 6 பார்க்கச்சுல எனக்கு which is going to be a minimum value? Again 3 is going to be a minimum value. ஓகே, ஸோ பில இருந்து சிக்கு கனெக்ஷன் ஓவர். அப்படின்னா நான் ஏற்கனவே எனக்கு மெமரியில என்னெல்லாம் இருக்கு? 8ம் 6ம் இருக்கு. இப்போ நான் சில இருந்து எங்கெல்லாம் எனக்கு கனெக்ஷன் போகுது? 3, 4. நான் இப்போ எதெல்லாம் கன்சிடர் பண்ணணும்? 8, 6, 3, 4. Which is the least value? 3 is going to be my least value. So I take up 3. Next, இப்போ E வந்தாச்சு. This is how I try finishing it. Does anybody have any doubt in this? This is my Prim's. Can I proceed? Any doubt? Any
Ma'am, I
doubt? Can I?
hope they don't have any doubts, ma'am. You can proceed.
Okay. Yes, ma'am. Again, the same example. One more thing is generally for the sprints, crystals and all, by default, the same questions only will be asked. So again, we will just see another example. Yeah. So this is going to be an example for the Prims which we are going to take. So here I'm going to have my graph with the vertices. I have 7 vertices. So from V1 to V7, as I just said, we generally it's by we can take any vertex as a source, no problem. But generally we take V1 as a source. One more thing is minimum spanning treeல இதுதான் ஆன்சர் அதுதான் ஆன்சர் சொல்ல முடியாது. It is not going to be a unique tree. It is going to vary. So this is going to be my initial table which I going to frame. V1 are my vertices, known value, distance and my path. இப்போ நான் V1 சோர்ஸ்னு எடுக்கிறனால என்னோட டிஸ்டன்ஸ் வந்து நாங்க 0 போட்டிருக்கேன், பாத்தும் 0ன்னு போட்டிருக்கேன் against V1. So what will be my first step here? We have to consider V1 ல இருந்து எங்கெல்லாம் path போகுது. So that is why they've showed it with the dotted lines here. So okay, so எங்கெல்லாம் நம்மளுக்கு dotted lines இருக்கு? V3, V4, V2. So which path will I take? கண்டிப்பா நான் V1 to V4 தான் எடுப்பேன். Because it is going to be of a minimal value. So how will I draw the table here? So V1 ல இருந்து 1. So which path am I? Okay, which are the possible paths do I have? 2, 4 and 1 here. நான் இதை நான் எதை எடுத்துக்கிறேன்? 1 தான் நான் எடுக்க போறேன். பாத் வந்து எங்க இருந்து வருது? V1 ல இருந்து வருது. So because I'm going to take the V1, now V1 க்குள்ளது I will have to show it with the bold lines. Okay, so V1 ல இருந்து V4 க்கு கனெக்ஷன் வந்துருச்சு. நெக்ஸ்ட் நான் என்ன பண்ணணும்? நெக்ஸ்ட் கிராஃப் ஷோஸ் மீ V4 க்கு வந்து ஓகே. So V1 ல இருந்து V4 க்கு வந்துருச்சு. V4 ல இருந்து other possible connections I must check. இப்போ அது இது பார்க்கச்சுல again I have to find the minimal value and I will complete it. Does anybody have any doubt in this? Any doubt? Any doubt? Okay, thank you, sir. Thank you. Thanks a lot. Yeah. So again, with the one which I left here, let's just quickly finish this. So Prim's algorithm and the Kruskal's algorithm, which we were talking. So quick overview. ரெண்டு இதோட overview என்னதுன்னா, we are going to try finding the minimum distance. And இதுல வந்து difference is that Kruskal's problem of how we are going to solve is, in case of Kruskal's algorithm, we initially identify எதெல்லாம் என்னோட vertices. And then ஒன்னொன்னா connect பண்ணிட்டு வருவேன் randomly. Prim's algorithm, what we do is, we start from one point to another, we connect. Second, அதுல இருந்து எதெல்லாம் shortest distance. For example, நான் சென்னையில இருந்து மதுரைக்கு போகணும். So நான் சென்னையில இருந்து maybe what to say, I have come to திண்டிவனம். So நான் shortest distance திண்டிவனம்ல இருந்து மதுரைக்கு தான் நான் பார்க்கணுமே தவிர சென்னையில இருந்து மதுரைக்கு நான் பார்க்க கூடாது. ஏன்னா நான் ஏற்கனவே திண்டிவனம் வரைக்கும் வந்துட்டேன். Okay, this is the difference between both. So we have just completed all this. We'll just quickly go. In the red level, I was just talking. Minimum spanning tree is a tree which is not going to be unique. It keeps varying. And I prefer this path. Another person may prefer another path. Completed all this. The same Prim's algorithm which we were talking. I will share this with you all. The difference between the Prim's and the Digitras is being shown here. So Digitras will be explained in shortest distance. One more thing is, in case of Kruskal's, they say the algorithm is going to maintain a forest of trees. Here it is because we are going to maintain all the edges, all the vertices we are going to maintain. We have the collection, and then from there we are going to select whichever is being needed for us. Yes. Ma'am, that's all, ma'am. Any other queries?
Professors, if you have any queries, you can ask Sonia, ma'am. I think they don't have any queries.
Yes,
Thank
ma'am.
you so much for joining again, ma'am.
Thank you, ma'am. Thanks a lot, ma'am. Thank you very much. And sorry for the trouble regarding the
problem, ma'am.
presentation.
We were able to listen, no, ma'am. No problem.
Thank you, ma'am. Thanks a lot, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Yeah,
Bye.
yeah. We can leave, ma'am. Thank you.
Yeah, ma'am.